want to talk to you this lecture about IP addressing. This is a layer 3 address, as we talked about in previous chapters, that operates the network layer, the OSI model. IP addressing is important for several reasons, but the first thing you need to remember is, just like no two people who aren't living together can have the same address and expect the mail to be delivered properly, no two computers on the internet can have the same address. Now, this is not a daunting situation if you think, okay, no two computers on my network of 5 workstations can have the same address. But you have to understand that when you're dealing with the internet, you're dealing with a network. No two computers, servers, whatever, on the internet can have the same address. You cannot duplicate the same address anywhere in the world. Now, there is a exception to this rule that you can manipulate, but we'll cover that in another chapter. It's called Network Address Translation. We'll get to that in another chapter. But for right now, you need to know how the powers that be came up with the network addressing scheme that we know as IP version 4. They have to do 2 things with an address. They have to identify a station by what network it's on, and then once they've identified the network, they must identify which node on that network there is. Therefore, test question, every IP address is made up of 2 parts, the network portion and the node portion. And you're going to have to know by looking at the number what portion is network and what portion is node. Before you can do that, you're going to need to know the classes of IP address. Now, there is a class A, B, C, D, and E. You are not going to be concerned with D and E. You will not have to deal with D and E unless you're working for the government or some other organization that deals with IP addressing and how to do research with them. So let's take a look at the Class A first. In the Class A network, supposing that you got assigned to Class A network, what would that Class A network number look like? That's a Class A number. Why? Because it's a 10, sort of. If it was an 11, would it be a Class B? No, it would still be a Class A. Because the first octet of an IP address identifies what class it is. According to the chart on your book, excuse me, if the first number is between 1 and 126, it's a Class A number. That number is between 1 and 126. Therefore, this is a Class A address. What does that tell you? It tells you that your default subnet mask will look like this. I put slots in them because the red may not show up quite as well as the black does. When you look at the subnet mask, all binary 1s in an octet represents the network. All binary 0s in an octet represents the node. That means that the network portion of this address is the first octet only. And that the 3 zeros following it represents the node portion. Okay, how do I assign these numbers? Important rule. First number is not usable. The 10, 0, 0, 0, you cannot assign that number because that represents the entire network. The last number in this entire range is not usable because it's a broadcast number, and we'll get to what that number is in just a minute. But if I want to assign an IP address to a workstation, and this is my scheme, what will that number be? 10.0.0.1. That's my first number. Okay, now I have another station. What number do I assign? 10.0.0.2. Oh, so you're just going to do them in numerical order? Absolutely. Until what? You cannot have any number that cannot be represented by binary code in an 8-bit range. In other words, zeros, ones, any combination thereof, as long as there's 8 of them. 8 ones is 255. 8 zeros is 0. That means there can be no numbers on this board that do not fall within the range of 0 to 255. Which means as I'm going down through here assigning numbers, and I get to 254, what do? You assign 255. But I thought you said you couldn't use the last number. It's not the last number yet. I can assign a 255. All right, if I assign a 255 and I want to do another one, what do I assign? I assign a 10.0, .1.0. What's the next one? 1.1. What's the next one? 1.2. What do I do when I get to 1.255? You go to 2.0. And what do I do when I get to 2.255? I go to 3.0. What do I do when I get to 255.255? Then you do a 10.1.0.0. And then you start the whole process over again. Well, how many numbers are in this address? 16 plus million. I'm not going to write them on the board. You keep going until, here's the trick, the magic last number. When you assign the number 10.255.255.254, you've gone as far as you can go. Why? Because if you do 255, 255, 255, you've hit the broadcast number. You can't use it because then the entirety of the node portion of the address is represented by binary ones, and you can't do that. That's the way a Class A IP address works. Let's look at a Class B. A Class B will begin with a 128 to a 191. Before we go any further, I want you to notice that this ended with a 126. The next one begins with a 128. What happened to 127? It's an unusable number because within that range is a loopback address that's used for checking whether you've configured IP correctly, and it's also used for research. 127 is omitted from the class of IP address range. So if it begins with a 128 to a 191, you're going to notice then that the first octet must be within that range, and they might assign you something like 130, excuse me. But in a Class B, whereas in a Class A, they assigned you the first octet, which is the network address, and allowed you 3 octets for a node address. In this one, 2 octets are going to represent the network, so they're going to assign you another number. Well, what would that number be for a Class B? The only thing that designates the class is the first octet. The next number is going to be anything between a 1 and a 254. So let's say it's a 160. The rest are going to be zeros. Okay, my subnet mask is going to change because remember, binary ones represents the network portion. Binary zeros represents the node portion. Binary ones, network portion. Binary zeros, node portion. my subnet mask is changed. Okay, I was allowed to manipulate these 3 octets in my class A. What about these? Well, the only reason I was allowed to manipulate those is because it's the node portion of the address. So don't be concerned with how many octets you can manipulate. Be concerned with the rule, you can only manipulate the node portion of the address. And in this case, it's these 2 octets. So I can start with a 130.160.1, and when this gets to be a 255, I go to a 130.160.1, 255, 20, and continue just like I did with these until I get to the number. And I stop, because the next number is the last one. It's the broadcast address, you can't use it. The first number, 130.160.00, is the network number, you can't use it. The last one with 255, you can't use it, and this will become more important in a later chapter when we start subnetting these, and that's complicated enough to where we don't include it in this lecture. Okay, let's take a look at a Class C, and that's as far as we're going to go, just a Class C. A Class C is going to begin with a 192 through a 223. That means, remember, we're only referring to the first octet. The first octet will fall within that range. So if we have a 207 in the first octet, you can look at that number and say, this is a Class B. One other thing I want to point out, that the A had 16 million plus. This Class B has 64,000 plus. And we'll see what this one has in a minute. But if we follow the same pattern, we know that this one, the network portion, this one, network portion. Does that mean that this one is going to have 3 octets as a network portion? Yes, it does. And so your number would look something like this. What's my subnet mask going to look like? That means I can only manipulate the all binary zeros. I'm only dealing with 1 octet. I can use 0 through 255, but I cannot use the first. I cannot use the last. I can use 1 through 254, which means with this addressing scheme, I have 254 usable addresses. You cannot mix the subnet mask for an A with the subnet mask for a B yet. This is the basic of IP addressing. This is the way the IP address runs. Now, it would seem that there's more numbers if I can go to 255 higher than a 223. That's where you get into the class D and E that you don't use. These are the 3 that you're going to be concerned with as long as IP version 4 is being used. And it's apparent that IP version 4 was going to be around for a while. Yes?
I have just a quick question. If there are 255 addresses in that range, and if you can't use the first one, you can't use the second one, does that not only leave 253 usable?
You got to start counting with 0. 0 through 255 is 256 numbers. Thank you. Good question.